Hello, Professor and everyone. My name is David An, and today I'm gonna present about antiderivative. As we have studied how to find the derivative of a function, however, many problems require that we require a function from its no derivative. For instance, we may know the velocity function of an object falling from an initial height and needs to know its height at any time. More generally, we want to find a function f from its derivative f. If such a function f exists, it's called an antiderivative of f. We will see in the next chapter that antiderivatives are the link connecting the two major elements of calculus like derivative and definite integral. Now let's start with the definition of antiderivative. It says a function f is an antiderivative of f on an interval I if f prime of x equal to f of x for all x in I. Example 1. Find an antiderivative for each of the following functions. F of x equal to 4x, g of x equal to sine of x, h of x equal to 4x plus sine of x. To solve the problem, we need to think backward here. What function do we know has a derivative equal to the given function? F of x equal to 2x squared, g of x equal to minus cosine of x, h of x equal to 2x squared minus cosine of h. Each answer can be checked by differentiating the derivative of f of x equal to 2x squared is 4x. The derivative of g of x equal to minus cosine of x is sine of x. And the derivative of h of x equal to 2x squared minus cosine of x is 4x plus sine of x. Theorem 6. If f is an antiderivative of f on an interval I, then the most general antiderivative of f on I is f of x plus c, where c is an arbitrary constant. Example 2. Find an antiderivative of f of x equal to 3x squared that satisfies f of 1 equal to minus 1. Since the derivative of x cubed is 3x squared, the general antiderivative will be f of x equal to x cubed plus c. Give all the antiderivative of f of x. Then the condition f of 1 equal to minus 1 determine a specific value for c. So we substitute x equal to 1 into f of x equal to x cubed plus c, give us that f of 1 equal to 1 cubed plus c and is equal to 1 plus c. By solving the equation 1 plus c equal to minus 1, so we got c equal to minus 2. So f of x equal to x cubed minus 2. Now let's see the figure 4.48. The curve y represents x cubed plus c via the coordinate plane without overlapping. In the example 2, we identify the curve y equal to x cubed minus 2 as the one that passes through the given point 1 and minus 1. Now, this is the table 4.2, and it's about the antiderivative formula, which is k is a constant. So this row shows the function, and this row shows the general antiderivative. 1 h to the power n, and its general antiderivative is 1 over n plus 1, h to the power n plus 1 plus c, where c is not equal to minus 1. 2. Sine of kh equal to minus 1 over k cosine of kh plus c. 3. Cosine of kh equal to 1 over k sine of kh plus c. 4. Secant square of kh equal to 1 over k tangent of kh plus c. 5. Cosecant square of kh equal to minus 1 over k cotangent of kh plus c. 6. Secant of kh multiplied by tangent of kh equal to 1 over k secant of kh plus c. 7. Cosecant of kh multiplied by cotangent of kh equal to minus 1 over k cosecant of kh plus c. Now, let's look at the example 3. Find the general antiderivative of each of the following functions. f of h equal to h to the power 4, g of h equal to 1 over 2 multiplied by square root of h. H of h equal to cosine of 4h, I of h equal to sine of h over 3. In this case, we can use one of the formula listed in table 4.2. F of h equal to h to the power 5 over 5 plus c. It's the formula 1 with n equal to 4. G of h equal to square root of h plus c. It's the formula 1 with n equal to 1 over 2. H of h equal to sine of 4h over 4 plus c, where the formula 3 with k equal to 4. And the last one, I of h equal to minus cosine of h over 3 plus c, which is the formula 2 with k equal to 1 over 3. Other derivative rule also lead to corresponding antiderivative rule. As we can see in the table 4.3, antiderivative linearity rule. 1. Constant multiple rule, k multiplied by f of h. And when f of h become the general antiderivative, it also equals k multiplied by f of h plus c, where k is a constant. 2. Negative rule, minus f of h. When f of h is general antiderivative, it's also equal minus f of h plus c. And the last rule is sum or difference rule. F of h plus or minus g of h, it's become f of h plus or minus g of h plus c. Example 4. Find the general antiderivative of 3 over 2 square root of h plus cosine of 4h. We have that f of h equal to 3g of h plus h of h for the functions g and h in example 3. Since g of h equal to square root of h is an antiderivative of g of h from example 3b, it follows the constant multiple rule for antiderivative that 3g of h equal to 3 square root of h is an antiderivative of 3g of h equal to 3 over 2 multiplied by square root of h. Likewise, from example 3c, we know that h of h equal to sine of 4h over 4 is an antiderivative of h of h equal to cosine of 4h. From some rule for antiderivative, we then get that f of h equal to 3g of h plus h of h plus c. As a result, we got 3 square root of h plus 1 over 4 sine of 4h plus c is the general antiderivative formula for f of h, where c is an arbitrary constant. Indefinite integral. A special symbol is used to denote the collection of all antiderivative of a function f. The collection of all antiderivative of s is called the indefinite integral of f with respect to h, and it's denoted by the collection like we see in the box of definition. The symbol is an integral sign. The function f is the integrand of the integral, and the x is the variable of integration. After the integral sign in the notation, we just define the integrand function is always followed by a differential to indicate the variable of integration. We will have more to say about why it's important in chapter 5. Using this notation, we restate the solution of example 1 as follows. Integral of 4x dx equal to 2x squared plus c. Integral of sine of x dx equal to minus cosine of x plus c. Integral of 4x plus sine of x dx equal to 2x squared minus cosine of x plus c. And the last example is evaluate integral 4x squared minus 8x plus 7 dx. If we recognize that 4 over 3x cubed minus 4x squared plus 7x is an antiderivative of 4x squared minus 8x plus 7, we can evaluate the integral f integral of 4x squared minus 8x plus 7 dx equal to 4 over 3x cubed minus 4x squared plus 7x plus c. And if we do not recognize the general antiderivative right away, we can generate it term by term with the sum, difference, and constant multiple rule, as I mentioned in the box above. So the problem is integral 4x squared minus 8x plus 7 dx equal to 4 multiplied by integral of x squared dx minus 8 integral 8 dx plus 7 integral dx. So we got 4 over 3x cubed plus c1 minus 4x squared plus c2 plus 7x plus c3. And we got the final result is 4 over 3x cubed plus c1 minus 4x squared minus c2 plus 7x plus c3, which is the same result as the general antiderivative like I mentioned before. That's all for my presentation. Thank you for attention.